Hi, Poema, it's Mrs. Herbst. I've got your review here. Just looks like 5 or so questions to go over. So here's the first one that you missed. It was question 3. It says this graph shows a proportional relationship between the number of tulips and the number of daffodils in gardens planned by the Lindy Landscaping Company. So then it asks, what is the constant of proportionality? So the constant of proportionality, remember, if you take any ordered pair from the graph, any x, y ordered pair, we do the y over the x. So as I look through this graph, and we can't do it with 0, 0 because you can't divide by 0. So as I start looking at some of these points that intersect those grids in the background, I can see the point 1, 2, 2, 4, 3, 6, 4, 8, and 5, 10. Taking any one of those ordered pairs, we're going to do y divided by x. So if I take that first one, it's 2 over 1, which is just 2. That second one, 4 over 2, is also going to give me 2. They're all going to give me 2. It looks like you might have done it x over y because you got 1/2, but remember it's y over x. So the answer here is 2. Okay, on question 8, it asks which numbers are irrational. So irrational numbers are numbers that are not perfect squares. These are numbers that are also non-repeating, non-terminating decimals. Rational numbers can be written like fractions. So anything that's listed here that's a fraction is going to be rational. So that's why the 7/8 is not irrational because it's a fraction, so that makes it rational. You're looking for non-perfect squares. You might have had this one a little bit backwards maybe, although you did select pi. Pi is probably the most common irrational number. But 196 is 14 times 14, the square root of 196. So the square root of 196 equals 14. That makes it rational. 80 is not a perfect square, so that one should have been selected. The square root of 16, it comes from 4 times 4, so the square root of 16 is 4. That is rational. Pi is irrational, again, the most common irrational number probably. The square root of 12, there's not a whole number that you can multiply by itself to get 12. It's another non-perfect square. So that one should have been selected. And then again, 7/18 is a fraction. 14, the reason why perfect squares are rational is because you can write them over 1. So I can write both of these numbers over 1, 14 over 1 and 4 over 1, and that makes them rational because they can be written as fractions. Question number 12 says, which estimation technique will yield a solution that is farthest from the actual product? So your product is multiplication. We're multiplying negative 14.89 times 1.35. And I think on this one, I bet you just misread it because it says it's the farthest from, which means which method is going to give you the least accurate answer. You put rounding to the nearest whole number. That actually is one of the more successful methods of estimation. And so it should have been front-end estimation. And then also remember that front-end estimation, I don't know if this is one that they would have gone over in this unit or not, but that's that method of that usually just with addition and subtraction. So again, this is multiplication, but it's where you take the largest place value and you add or subtract those two numbers, and then you do round the decimal to the nearest 10th place, typically is how that's done. So that actually is the least accurate method of estimation. So that one we would not use. Hang on.
Please make your way to the front entrance. As the wall on your right is your front entrance.
Okay, on to question 17. This one says, Renee used the values in the table to calculate simple interest. Which interest rate is missing from Renee's table? So simple interest, there's a formula, and it's interest equals principal times rate times time. And so in this one, we're told the principal, we're told the interest, we're told the time, and we're trying to find the interest rate. So we're just going to plug these numbers in. So we're going to put $412.50 here. The principal, or the amount that we're calculating the interest on, is $750. We don't know the rate, so I'm going to keep that R, and the time is 11. Remember, all three of these back here, this is all multiplication, principal times rate times time. Time does have to be in years. It is in years here, so this is good. I'm going to go ahead and multiply these two numbers together, 412.50, and let me grab my calculator here. 750 times 11 is 8250, and I need to bring the R down. And now if I'm multiplying 8,250 times R and I get $412.50, I can divide, this is really solving a one-step equation, I can divide both sides by 8250 to figure out what R equals. So taking $412.50 and dividing it by 8,250 gives us 0.05, which you can see here is the answer you selected. But remember that that's the decimal, and we need to change it to a percent. We convert decimals to percents by multiplying by 100 or moving the decimal 2 times to the right. So it's 5%. Question 21 asks, what's the constant of proportionality? Y equals x over 9. So whenever we have an x in the numerator over a number, you can actually kind of pull that fraction out. This also could be written, since there's not a number up here with x, this is the same thing as saying 1/9 x, and so that's your constant of proportionality. I'm not sure where the 8 came from in the answer you selected. I don't know if maybe you looked at it too fast and thought the x was an 8, but you kind of just pull that fraction out. Here's another example. If it were something like y equals 2x over 3, here's an example where the x is in the numerator with a number. You still can kind of pull that fraction out and say that's the same thing as y equals 2/3 x. So there's another example of that same concept, but putting something up in the denominator with the x. And then the last one you missed was 25. Johnny rode his bike 4/7 of a mile from his house to the lake on a straight path. Then he turned and rode his bike 3 1/8 miles in the opposite direction. About how far is Johnny from his house? So if we look at a number line, oh, that's an eraser. If we look at a number line, there's 0. So first he goes 4/7 in this direction. So this is not going to be to scale. It's just to kind of show where we're at and what we're going to do these numbers. Then it says he turned around and rode it in the exact opposite direction. So maybe he went east and now he's headed west. He's definitely going further past his house the other direction. And now let's say that this is 3 1/8 miles. So we're going to use positive 4/7, and we're going to add to that a negative 3 1/8. So that's what we should be doing here. And it says about how far. So this is another estimation. 4/7 is really close to a half, right? That'd be 4/8 or 3.57. So we have about a half. And then we're adding to that negative 3 1/8, and we want to round again to that nearest whole number. So we're adding a negative 3. And if we take a half and we add negative 3, we really get negative 2.5. But again, the question was about how far is he? And so when we talk about distance, we don't ever say that distance is negative. So that's why it's equal to 2.5 miles. Okay, so here's, this is just, again, me going over the questions that you missed. If you have any questions other than that before you go to take the final, just reach out and let me know. Talk to you soon.